In this video, we're going to continue sketching polar curves. And remember, polar curves live on the XY plane. And we're going to sketch it from that curve on the r theta plane. So let's do an example right away. So for example, we have this curve. R equals, or r of theta, let's say, is equal to 1 plus sine of theta. If we were just to plot this function, r versus theta, what I mean by that is, instead of using the xy plane, we're going to plot this on axes, that is r on the vertical axes, and theta on the horizontal axes. And if we just divide this up into a couple sections, say pi over 2, pi, 3 pi over 2, and 2 pi, well, if we're just to sketch this function, r equals 1 plus sine theta on the r theta plane, it would look like the following. When theta is equal to 0, r is equal to 1. When theta is pi over 2, r is equal to 2. When theta is pi, r is equal to 1. When theta is 3 pi over 2, r is equal to 0. And when theta is 2 pi, r is equal to 1. In other words, this is a sine curve that's just shifted up 1. And again, this is the r theta plane. This isn't the polar representation of the curve, because polar curves live on the xy plane. This is the curve on the r theta plane. So let's go step by step how to actually plot this on its home on the xy plane. And the way in which we're going to do this is going to be step by step, with a very similar feel to what we did for parametric curves, for that matter. And we're going to be asking ourselves, well, what happens to r between specific angular values? So for example, let's first consider what happens to r between an angle of 0, here, and an angle of pi over 2, which would be here. So, at an angle of 0, we know r is equal to 1, so we can move out a distance of 1. When r is at pi over 2, we know our r value is equal to 2. So along the pi over 2 direction, which is straight up ahead, or straight upwards, we know we're a distance of 2. Try to draw this just a little better. Okay. So, well, we know that r goes from 1 to 2, so it's increasing. So as we sweep along this angle from 0 to pi over 2, we know our r value just keeps getting larger and larger within that entire region. So we can draw this curve basically going like this. And you'll notice that, again, as we move that angle from 0 to slightly larger than 0, to around pi over 4, to pi over 3, etc., our r value, or the distance that we're moving from the origin, is getting larger and larger. Okay, so that took care of this first chunk. Let's look at the next set of values. We're moving from an angle of pi over 2. Again, that's an angle that's just straight upwards from the x-axis in the y direction to an angle of pi. And as we had before, well, we know that at an angle of pi over 2, r is equal to 2. At an angle of pi, which is along the negative x-axis, we're a distance of 1 away. Again, we're on the xy plane. So let's talk about what happens between those angular values. So again, the angle value at pi over 2 to our angle value at pi. R is going from 2 to R is 1. So as we are sweeping from angle values close to pi over 2 and getting larger and larger and moving towards pi, well, R is shrinking because we're going from a distance of 2 away from the origin to a distance of just 1 away from the origin in the direction of pi. So our curve is doing something like this. Okay, now let's talk about what happens between the next set of angular values. This will be the angle of pi, which is, again, straight in the negative x direction, to an angle of 3 pi over 2, which again would be straight downwards. We know that r is equal to 1 at an angle of pi, which we had before, but then at 3 pi over 2, our r value, well, it's 0. So let's talk about what must be happening. At an angle just slightly larger than pi, we know that, well, if we're an angle slightly larger than pi, r is still positive. It's just slightly less than 1. At an angle slightly higher than that, r is positive, but it's slightly smaller than what that previous value of r was. And we could keep doing the same thing as we march closer and closer to 3 pi over 2. And what we realize is this curve actually curves back from r equals 1 at pi to just the origin itself. And again, it's because when we're at a value or an angle slightly larger than pi, we know r is slightly smaller than 1. When we're at an angle slightly larger than that, we know r is smaller even. And as we march closer to pi over 2, our angle's getting close, or our r value's getting closer and closer to 0. All right, well, let's check out the next set of values. So we know 3 pi over 2, we're at an r equals 0. Well, at an angle of 2 pi, we're back to an angle of, or value of r equals 1. So at 3 pi over 2, again, we're looking straight down. At 2 pi, we are going out the positive x-axis. And we know we're at a value of 0 at 3 pi over 2. And we're landing at a value of r equals 1 at 2 pi. So moving out a distance of r equals 1, we are back kind of where our curve began. So let's check out what must be happening. Well, if we choose an angle slightly larger than 3 pi over 2, our r value is slightly larger than 0. If we move out next angle, well, our r value is slightly larger than that. If we keep moving out more and more angles away, our r value just keeps increasing and increasing, but we know that it actually can't increase more than a value of 1. So let's go ahead and talk about that again. Well, we're at an angle value slightly larger than 3 pi over 2. Our r is just barely greater than 0. So we're moving in that direction. We're just not too far away from the origin. As we move closer to pi, or 2 pi, our r value is going to keep increasing. Except we know it can't increase any further than 1 when we get to the angle of 2 pi. So this is what this polar curve looks like. Now again, this is just a sketch. It's a very crude sketch for that matter, but we can pick up on the big kind of aspects of what this curve looks like. And the important things that I want us to consider is we're really going, in this case, point to point or in region for region of where our angle values are, and asking what's happening to R between specific angular values. And we just keep marching along from an angle of 0 to an angle of pi over 2 to an angle of pi to an angle of 3 pi over 2 to back to an angle of 2 pi. So we're doing this very much point by point. And if we're just handed a polar curve, there is no reason that we should know what that curve looks like before sitting down and doing any of this analysis.